Hello friends, here I am going to show or here I am going to do the analysis of sheet metal working analysis in the Ansys, which will I do in explicit dynamic in Ansys workbench. First we have to select the engineering data. First we have to select the material in engineering data source. In general material we can find out the different kinds of the material, general non-material. In general non-material also you can find different materials. Okay, we select aluminum for the sheet metal, gray cast iron for the punch and the die. Okay, then we have to back into geometry, in which we will select are the geometry which I will import from SolidWorks software. So you have to if you want to watch uh, how to import a part from the different software, so you have to watch my first video is on how to import a part from the different software. Add material for our body and generate. Okay, so you look, this is a punch, this is a die, and in between you can see it here, this is a sheet. We put the velocity on this sheet and it's converted into the shape like this die shape. Okay, so we will look on it, then we back to our main page, the model. It will take a few time to open it according to your CPU memory. Geometry. For the sheet metal we will apply aluminum, and for the punch and the die we will apply at here the gray cast iron, and it's rigid. We apply the type is rigid, stiffness behavior. Okay, it's not flexible. Then we have to apply the contact. First we have to delete this by default contact, delete it, and then we have to apply the contact, insert, and then go for the manual contact region. Here we have to just apply the sheet and the die contact. We will not have to apply this punch contact to the sheet or to the die. In the contact region we have to apply this below face of the sheet metal, and for the target we will apply the above face of this die. Okay, so for this I have to hide this sheet. Then again back to the contact. For the target I'll apply this only face. Okay, because it is in the touch with our sheet. Apply. Here we have to do the another thing is type is a frictional, because when we apply the huge amounts of the velocity at that time the lots of amount of the heat is generated at here. Okay, uh, so it will help in our sheet working process. Our contact is done, then we have to go for the mesh. In the mesh different kinds of the method are available according to the complexity of the part. Here if the complexity is high, so in sizing we have to apply the proximity and curvature. If the R size is not, or the geometry is not in the complex shape like this geometry, so we have to apply the off. Then we back to the explicit dynamic analysis. We will do it here in analysis setting in end time. we have to apply just a little bit time, 5. Here in the end time we just apply the 1 second. If you can apply the any kinds any amounts of the time, 1 minute, 10 second, 100 second, but if we apply the less amount of the time, so in analysis setting or in the solution setting in solving this mathematical model, it will take a little bit time. Okay, so for that reason I apply just only the 1 second. Then in explicit dynamic we have to insert the velocity. For this punch we apply this region for the velocity. So here for you can choose, if you choose the this command, so you can just choose that here only just point, this for the edge, this for the face, and this for the whole body. So here we apply the whole body for the velocity, and here you can see the y direction is above side, but we have to apply the velocity in downward side. So in y component here we apply minus velocity, minus 10,000 per second velocity we applied at here. This is the best velocity for punching operation. If I apply the less velocity in punching operation, so we will not find a good enough result for this body or for this geometry. And if I apply the higher amounts of the velocity as compared to the uh, minus 10,000 per second, so it will be deleterious for our the sheet. Okay, we will see in the solution. Then we apply the fixed support for this body, whole body we have to fix this body, because when we apply the velocity in this sheet metal, so we have to for that reason we have to fix this, because when we apply, if it is not fixed, then it's a move when we apply the velocity into the punch and apply. Then we have to fix another region, these two side faces of the sheet metal, otherwise it moves when we apply the velocity and we will not find the good result. We will see if this fixed support when we not apply, what kinds of the result we will find out, and if we apply this fixed support, so what kinds of the result we will get. Then for the solution, here we can see the total deformation and the 1 minus stress. Then solve. It will take a few time. Okay, our whole process is done. Then we look for the total deformation. You can see it here, it's totally the mesh. Okay, in the okay, the solution, here you can press the animation button, so look perfectly, look at this. Here we set the frame rate very low, so we will find the best result at here. Okay, look at this, it's awesome. We hide the punch, so we look the better result of the sheet. Okay, look at here. At this point, you can find out the maximum deformation at the 21 mm. 21 mm deformation you can find at here at the red region, and at this region, blue region, you can find out the minimum zero deformation at here. Okay, we hide this body also, done. So look at this, what kinds of the shape we wanted to get from this sheet metal. Okay, as the punch shape and the die shape. Okay, these kinds of the sheet we get from this punch and the die. Okay, look on this. Here equivalent stress, in the stress we also find out the maximum stress at here. Maximum stress. We apply the too much velocity, that's why it's deformed. We apply the less amount of the velocity, so it will not deform like that. Okay, for the last time we will see the animations of the sheet metal working. For the more videos, you should subscribe my channel. Okay. Please subscribe and share my channel. Thank you.